Welcome students and viewers. In this video, we are going to look at MATH101, Sets and Number Systems, and specifically, we are going to look at equivalence relation. So remember, in our last video, we have looked at types of relation where we have seen the reflexive relation, and we look at the symmetric relation. We have also looked at the anti-symmetric relation, symmetric relation, and we have looked at the transitive relation. Relations. And what do we say these are? So a relation R on a non-empty set S is said to be reflexive if for all A in S, A is related to A. A is related to itself. And this kind of relation, whenever A is being related to any other element in the set S, then A must be related under R, then A must be related to itself under R. So we look at the symmetric relation, and this symmetric relation simply means that whenever you have A is related to B, then you have what? B is also related to A. So this symmetric relation simply means the reverse or the inverse of the relation A related to B is also in R, meaning the relation R contains the inverse of AB. If you have A related to B, which we write as AB, the ordered pair AB, simply means that also whenever you have this is in R, meaning A and B are R related, then definitely this will imply B is also related to A. We have the anti-symmetric relation. The anti-symmetric relation simply means that whenever you have A is related to B and B is related to A, then you have what? A and B are equal. Whenever you have two elements that are related and inversely unrelated, definitely the two elements are equal. So we have the transitive relation. And this relation simply means if you have A is related to B, if A is related to B and B is related to C, definitely A is related to C. So this kind of relations we have discussed in our last video. In today's video, we are going to look at equivalence relation, definition. So we begin by definition. A relation R on a non-empty set, call it S, is an equivalence relation if R satisfies the following. So, 1, R is reflexive. 2, R is symmetric. 3, R is transitive. That is, as we have just defined what is reflexive, that is for all A inside S, then if you have any relation with A, then you have A is self-related to A. And secondly, you have R is symmetric, that is if A, whenever there is A related to B, A is related to B, it implies B is also related to A. And lastly, if A is related to B and B is related to A, B is related to C, then A is R related to C. So if you have A is related to B and B is related to C, you can directly, if A is related to B and B is related to C, you can directly say A is related to C. Whenever these three conditions are satisfied by a relation R, then this relation is called an equivalence relation on the set S. So example, so in today's video we are going to check example number 1. Example 1. So let R be equal to, we have our relation to be 1 related, so let's take A is related to B, and then B is related to A. You have A related to A, so A related to A, and you have B is related to B. Maybe you have C is related to C. So this relation, consider it on S, a non-empty set equals to A, B, C. The question is, is R an equivalence relation? Is R an equivalence relation? So for us to agree or to answer the question that R is an equivalence relation, we have to test the three conditions here. Is R reflexive on S? So we look at, is it reflexive? There are how many elements here in the relation that appear? We have A, B, and C. So, is A related to A? We have A related to A. We have B. Is B related to B? So we have B is related to B. Do we have C related to C? Yes, we have C is related to C. So we have seen reflexivity has appeared now. Let's look at symmetry. So you have AB. So we have AB. Do we have BA? So we have AB and we have BA. So meaning the relation is what? Symmetric. Let's look at, do we have any other one? So AA is the same AA, BB is the same BB, CC is the same CC. So this one is also symmetric, this is also symmetric, this is also symmetric. And this is also symmetric. This one is also symmetric because of this. And so we have seen symmetric property. R is transitive. So is it transitive? Whenever A is related to B and B is related to A, do we have A related to A? Yes, we have it. So B is related to A and A is related to B. So do we have B related to B? Yes, we have it. So these ones are direct. We don't need to check further. So the relation is also transitive. And so the relation R is an equivalence relation. So we can answer the question now. Say the relation R is an equivalence relation. On the set S. So example 2. Example 2. So in this example, we are going to use example 1 to give another relation. So let R be equals to, so we took a sub relation of this. So we have A is related to B, so B is related to A, and we have A is related to A, and we have B is related to B. This is also an equivalence relation on the set S. Look at it. A relation is just a subset of a Cartesian product of S. So here, the relation R that we have is a subset of S cross S, which we write as R is a subset of S squared. So it's just a subset. It's not necessary that all the elements of S appear in the relation R. But whenever an element appears in the relation R, then it must relate to itself. And that is reflexive property. So you look at A has appeared. So whenever A appears, A must relate to itself in that relation. And so you have A is related to A, and that is what? So B has appeared, so you have B is related to itself. And so you have seen reflexive. So we have seen reflexive. The relation is reflexive. Is it symmetric? We have AB and there is BA. We have AA, AA, BB, BB. And this means that the relation is symmetric. Is it transitive? We have A related to B and B is related to A. Clearly we can directly say A is related to A, and we have A related to A in the relation. We have B related to A and A is related to B. Therefore, we have B is related to B, and it is here in the relation. And so the relation is what? Transitive. And therefore, this means the relation is an equivalence one. Meaning the relation is an equivalence relation.